Let's see about cluster analysis today and what are the different data types of cluster analysis, and then we'll be seeing very elaborately about the binary variables in this video. The remaining variables we'll be seeing in the forthcoming videos. Cluster analysis. What is cluster analysis? Cluster, as the name indicates, is a collection of data objects, cluster of objects. So in the cluster, the similar objects which is related to each other will be in the same cluster or will be in the same group, and the dissimilar, which are not correlated or not related, will be in the different groups. So anyhow, we'll form the clusters where the related objects will be present in one clusters. The unrelated or the different objects or the dissimilar objects will be present in the various other clusters. What is cluster analysis? So finding the similarities between the different data according to its characteristics found in the data and grouping the similar data objects into clusters. So it could be anything depending upon the similarity based on any categories. It could be their characteristics, or it could be their how they behave sort of characteristics. So basically depends on the characteristics, the similarities between the data are actually found, and those will be grouped together. The similar objects will be grouped together, the unsimilar or the dissimilar objects will be grouped separately. So that is what is called cluster analysis. I'll give you an example. Suppose if you take a classroom. Suppose if we say that the people, those who secure 10% can be put in one cluster. Those who secure from 75 to 90% could be put in one cluster. And then you can put the people, those who pursue the percentage from 5% to 7.5. So likewise, we'll be grouping the people based on the characteristics. So in this cluster analysis falls under unsupervised learning. There is no any predefined class. So these algorithm will learn by the observations, whereas there is another learning called supervised learning, where it learns by the examples. There is also another learning called semi-supervised learning, and also the reinforcement learning, but we are not going to see all this. As of now, cluster analysis falls under unsupervised learning, where you do not have any predefined labels or classes for unsupervised learning. So the typical applications of the cluster analysis are as a standalone tool to get insights into data distribution, also as a pre-processing step for various other algorithms. So these are the typical applications of the cluster analysis. So there are four important types of data in cluster analysis: interval scaled variables, binary variables, nominal, ordinal and ratio variables, variables of mixed type. So one by one we'll see in our forthcoming videos. In this video, we are going to concentrate on the binary variables. We know what is binary variables. As the name indicates, binary variables. So 0 or 1, yes or no, positive or negative, only two values, binary. Okay. So how to compute the dissimilarity between the objects described by either symmetric or asymmetric binary variables. Okay, so first I'll tell you what is binary variable, then we'll come into the concept symmetric and asymmetric or asymmetric. So as I told you, a binary variable have only two states, which is 0 or 1. So 0 could be absent, 1 could be present. So treating binary variables as an interval scaled, or treating the binary variable as a ratio scaled, or treating the binary variables as a different variable, then the result could be not accurate. If it is a binary variable, the proper computation needs to be done for the binary variable. If it is an interval scaled variable, there is a different computations for the interval based scaling variables. If it is a ratio scaled variables, then different computation needs to be performed in order to find the similarity between the objects and dissimilarity between the objects. So here there is a 2x2 contingency table is being followed to compute the dissimilarity between the objects. So this is the contingency table for binary variables. So this is a table. You could see you have an object I and you have an object j. So in case the object I is 1 and object j is 1, the value is Q. If the object I is 1 and object J is 0, the value is R. If the object I is 0 and the object J is yes, the value is T. So when you add up this values QR, the sum would be Q plus R. Then the add up these values S and T, the value will be S and T. And if you add up the value of Q and S, the sum will be Q plus S. And if you add up R and T, the sum will be R plus T. So the total of Q plus R plus S plus T would become a P. So this combination you should keep in mind in order to solve the problem for binary variables. So now the total, as per the contingency table, the total number of variable is P, which is nothing but Q plus R plus S plus T. So what is Q? As I told you already, so it would be the value of object I1 and object J1. Okay, so as per that the values will differ. So this binary variable is symmetric if both of its states are equally valuable and carry the same weight. So as I told you in the previous slide, what is symmetric and what is asymmetric? Symmetric is nothing but, suppose you have a gender, male and female. Let us say, do you have any weightage for male? Male is very higher priority and female is a low priority. No, both are same. So in that case, there won't be any weightage for 0 and 1. Both are equal. Likewise, gender, male and female is called a symmetric variable because it does not have any high weightage or high priority for male or for female. So the gender, you could call it as a symmetric variable. So in that case, there is no preference on which outcome should be coded as 0 or 1. So the dissimilarity function will be R plus S divided by Q plus R plus S plus T. So this is the formula, dissimilarity formula for the binary variable if it is symmetric. So this is what they have told. Dissimilarity that is based on the symmetric binary variable is called symmetric binary dissimilarity. And then what is asymmetric value? So asymmetric value, you can say, let's take an example of COVID lab test. In case if the COVID lab test is positive, that has a different weightage. If it is negative, obviously that have a different weightage. So the positive and negative, 0 and 1. If it is a negative, you can say 0. If it's a positive, you can say 1. If it is a negative, you can say no. If it is a positive, you can say yes. So these two binary variables have different weightage for their states. Both the outcomes of the states are not equally important, such as negative and positive outcomes of a disease test. So this is what is asymmetric variable. I hope you people would have understand what is symmetric and asymmetric variable. Okay, now let's see the formula. So as I told you, there is a contingency table for the binary data. Here we are going to see the formula for the symmetric binary variable and asymmetric binary variable, and there is also a concept called similarity here. Till now we were seeing about the dissimilarity of the data. There is also a concept called similarity because we know that when you are going for the cluster analysis, we groups the data based on the similarity of the object, and also we group the data based on the dissimilarity of the object. So the similarity also should come into the picture. So here object I and J, for 1 and 1 I have given A, for 1 and 0 B, for 1 and for 0 and 1 it is C, for 0 0 it is D. You can also take it as for yes and yes A, for S and no B, for no and yes C, for no it's D. So the sum of it is A plus B. The sum of this is this row is C plus D. The sum of this column is A plus C. The sum of this column is B plus D, and the total value is P. So now let us see the distance measure for symmetric binary variable. So the dissimilarity between the I and J object is B plus C divided by A plus B plus C plus D. So the distance measure for the asymmetric binary variable is B plus C divided by A plus B plus C. And the similarity measure is also called as Jaccard coefficient, where the similarity of the object I and j is nothing but 1 minus dissimilarity of I comma j. So through this formula, we are going to solve the problems. Usually the distance measure for symmetric binary variables will not be taken into consideration because there is no any outcome weightage. There is no any weightage for the outcomes. Whereas the distance measures for the asymmetric binary variable problems will be solving in the next slide. Okay. As I've already explained you, the binary variable that contains two possible outcomes, one which could be positive or present, or a 0 which could be negative or absent. If there is no preferences for which outcome should be coded as 0 and which should be 1, because we can say that, can you say me like whether male can be coded as 0 and female can be coded as 1? Does it means that male is 0 and the female is the first number? No, nothing like that. So you do not have any preference and do not have any priority or any rule that male should be 0, female should be 1, or female should be 0 and male should be 1. So you cannot give any preference. In that case, the binary variable is symmetric. And just for an example, if the binary variable is evergreen, for a plant has the possible states, loses leaves in winter and does not lose leaves in winter. So both are equally valuable and carry the same weight when a proximity measure is computed. If the outcomes of a binary variable are not equally important, the binary variable is called asymmetric. For example, if you take a color blindness, so a variable is the presence or absence of a relatively rare attribute such as color blind for the human being. Suppose if two people who are color blind have something in common, the same thing you cannot say for the people those who are not color blind. Okay, so that's what, when you have a preferences or a weightage for the outcomes, that you say it as a asymmetric variable. Now let's see the example, as we have already seen the Jaccard coefficient. So dissimilarity is r plus s divided by q plus r plus s. Can you say what is this formula is for, symmetric or asymmetric? This is for asymmetric. Okay, so now through this dissimilarity function, we will be finding the Jaccard coefficient, which is nothing but 1 minus dissimilarity of the asymmetric. So this coefficient, similarity of I comma j, is considered to be the Jaccard coefficient. Now comes the example, how to find the dissimilarity between the binary variable. So now when you take this example, I have three names or three persons, Jack, Mary and Jim. So Jack is a male, Mary is a female, Jim is a male. So as we know, gender is asymmetric and we are going to code this for asymmetric because we cannot take male as 0, female as 1. It could be anything. This varies. So because of this varying, the output cannot be perfect, because I can prefer male to be 1, you can prefer male to be 0. So in that case, you will not get a proper dissimilarity between the binary variables. That is why I am not going to use, I am going to discard this gender as this is a symmetric variable. Now let us take the other attributes, fever, cough, test 1, test 2, test 3 and test 4. Okay, fine. So now let us take Jack, Mary and Jim with all these attributes. So the gender is a symmetric attribute. The remaining attributes are asymmetric binary. So let the values of y and p to be set to 1. So the s is set to be 1 and the value of n is set to be 0. Let us say s is to be 1, positive. 1, negative, no, negative, let it be 0. We are setting it since it's a asymmetric. Now let us take, this is the formula for the dissimilarity of the asymmetric variable. Now let us first consider the find the dissimilarity between the binary variables Jack and Mary. Now let me take the Jack and Mary. So my first formula is R, which needs 1, object I needs to be 1 and object J needs to be 0. So now let us find 1 and 0. So here Jack and Mary 1 1. This is yes is 1. So what happens? This is 1, this is 1. So it comes here 1 and 1. So I cannot do anything here. So now let me use a pen. So this is 1, this is 1. So my R needs to be 1 and 0. So this will not come into this picture. This will be 0 and 0. Okay, no, R cannot be, because R should be 1 and 0. So now here comes 1 and 1 again. No, I do not have any r here. Now I have 0 and 0. I do not have r here because 1 and 0 will be the r, and I have 0 and 1. But my r is 1 and 0. But here it's 0 and 1, so it cannot be the r. So here 0 and 0. So now in this case r is 0. R is 0. Now when you come to S, the object I should be 0 and the object 1 should be 1. So let us see 1 1 0 0 1 1 0 0, and I have one part which is 0 and 1. 0 and 1 for yes. Yes, I have 1 zeros and 1s. Now when you come to Q, which is nothing but 1 and 1. So I have 1 and 1 here, 1 and 1 here. So 2, 1 and 1, 2 possibility I have. So the value of Q is 2. And as we know, R is 0 and S is 1. So the value is 0.33, which is 1 divided by 3, which is 0.33. Now let us find the dissimilarity between two binary variables, Jack and Jim. Jack and Jim. Now let us consider for R the value should be 1 and 0. So here it is 1 and 1. No. It should be 0 and 1 here. No, because our value should be 1 and 0. So here you have 1 and here you have 0. Yes, I have one possibility. So this comes, and here it is 0 and 0, 0 and 0, 0 and 0, and this is also 0 and 0. So I have the possibility of R in the Jack and Jim is only test 1. So 1. And then when you come to yes, what happens? It should be 0 and 1. So 0, 1, 1. Yes, I have cough as 0, 1, 1. And then that's all. So I have only one possibility, that is yes. And then for Q, both needs to be 1. Both needs to be 1. So I have this possibility, fever as possibility. Yes, that's all. Fever as the possibility of Q. And we know the value of R and yes, 1 plus 1 plus 1, which is 2 divided by 3, which is 0.67. Okay. And then now you come to the concept called dissimilarity between the other binary variable, which is called Jim and Mary. So Jim and Mary, we are going to find it out. So when you come here, the value of R is, what is R? 1 and 0. So 1 and 0. So Jim should be the first object I. Okay, you should see like this, 1 and 0. No. 1 and 0. Yes, I have one possibility, which is cough. No, 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 no. So only one R, which is 1 and 0 I have. When you come to S, then you should have 0 and 1. You should have 0 and 1. Let's check here. 0 and 1 is not here. 0 and 1 is not here. Yes, I have a 0 and 1 here. And no, 0, 0, 0, 1, 1 here. Right, I have two possibilities. Here also it's not there. 0, 0. So I have two possibility of yes. Got it? So now Q, 1 and 1. So it should be 1 and 1. Yes, I have a possibility here. Yes, only one possibility I have here. So 1Q, as we know already, R is 1 and S is 2. So you will have 3 divided by 4, which is 0.75. So likewise, you will be calculating the dissimilarity between the binary variables. Hope everybody understood what is cluster analysis, and what are all the different types of data you have in cluster analysis. And in this video, we have seen about the binary variables. What is binary variable? What is asymmetric binary variable? What is symmetric binary variable? And how to find the dissimilarity between the symmetric variables, and how to find the dissimilarity between the asymmetric variable. And what about the similarity distance measure, which is nothing but the Jaccard coefficient. Also, example has been seen on asymmetric binary variable. Hope everybody understood. Thank you.